Hello, everyone, and welcome back to Aviz Networks podcast series. I'm your host, Shruti Jha, Digital Marketing Manager at Aviz Networks. And today we're going to talk about something every network engineers can relate to: the growing complexity of network operations and how AI co-pilots are changing the way team works. Joining me today is Perumal, CTO and co-founder of Aviz Networks. Chid brings more than 20 years of experience designing and building software for enterprise and cloud networks. Before founding Aviz, he held software architecture and leadership roles at Amazon AWS, Lenovo, IBM, and Blade Network Technologies. He also holds multiple patents in SDN, network observability, and enterprise switching and routing. And today leads Aviz's integration of generative AI into enterprise networking platforms. Chit, it's great to have you with us.
Thank you. Thank you, Shruti, for the quick introduction. Happy to be here.
So, Chit, we have been hearing a lot from our network engineers and IT teams who feel overwhelmed by day to day operations. So, let's just start there. To begin with, can you paint a picture of what day to day life looks like for today's network engineers? What are they constantly juggling with?
Absolutely. Leading the engineering team for quite some time now, I would say the majority, the challenges, right? The way today's network engineer operates is they have this. They were always in the state of multiple context switching. Why? It is like because they move from various dashboards to logs, from CLI sessions to looking at the run books, and from the alarms and events coming against the telemetry feeds what they have, all within in a span of few minutes, right? If they want to troubleshoot a single issue, or if they want to even debug a problem, they need to correlate from different tools. I would say, based on my experience, for a network problem to look at it, we should be looking at more than five tools to look at identify the root cause and understand what's happening in the network. It's not like looking at a dashboard will solve the problem, right? And the biggest challenge here is, right, every tool or every dashboard, right, they speak their own language and it shows only the part of the truth, right? So in a nutshell, they are not troubleshooting a single-threaded simple problem. They are looking at a distributed system under high pressure to meet the deadlines and trying to stitch together all these mental models in real time. So it's cognitively heavy work.
Yeah, so now that constant switching between tools, alerts, tickets, and teams, this can be very exhausting, right? So, why is this so taxing and how does it impact productivity, accuracy, and ultimately burnout within network operations team?
So you said context switching, right? Because every context switch, if you really look at it, right, it forces the engineer to reconstruct the whole network state in their mind, or probably nowadays, not nowadays, every day we do it in the scratch pad, right? So
Mhm.
they do this. They need to reconstruct the whole thing, right? And when they do this multiple times a day and repetitively looking at this an issue, trying to debug a problem, there the accuracy drops because you start making assumptions on what you see and say that, okay, oh, I have seen this in the previous thing and this might be probably the root cause, and you start the accuracy drops, right? And what happens is eventually it increases the probability of making a mistake, doing some misconfiguration, or and then it burns out the network engineer itself. The big challenge is not about the skill here, actually. It's about the amount of fragmented data they have to juggle to come to a resolution.
And networks, we all know that it's not run by a single team anymore. We have NetOps, NOC, SRE team, architects, IT leaders, and procurement, you name it. So, how does this diversity of roles complicate decision making and communication?
So the network is seen via different lens. If you really look at the various teams, right? And if I see SRE teams, right, they look at the network as for the issues and symptoms. That's the first thing, right? Network operations team, they see the root causes, what is happening if a problem happens, right? Architects, they look at, okay, this is my current design, and what is the expected design behavior with this design? Is it operating the same way, right? And when it comes to the business leader, they are looking for outcomes and business impacts, right? Is my network effectively used or not? So these are the four different perspectives how the personas look at their networks.
And in those environments, the same data, they often get interpreted very differently depending on the audience. How does that happen in practice? Can you maybe share an example where different stakeholders drew different conclusions from the same network signals?
Absolutely, absolutely, I can. So I can start with the typical, which is a common use case seen across the network, right? The typical thing is, how is your network traffic link utilization happening, right? Let's say that your network utilization is like 80% for a given time at a given time, right? The SRE looks at it, he says, "Oh, it looks fine. It's fine because the traffic is going. I don't see a problem there." But if it, from the NetOps perspective, they look at it. Oh, probably there is a microbus happening in the network. That's what they look at it, and they say maybe there is some traffic which is causing a burstiness into the network and which causes the increase in the utilization. Right. This is from the NetOps perspective because they're trying to figure out what is happening. Right. But then comes the network architect. He looks. Oh, you know what? According to our design, there is no oversubscription. We cannot hit this scenario. So there is something wrong. So are we missing in terms of the design? Did we not design the network for this kind of traffic behaviors? And then comes the business leaders who look at this utilization and say, "Hey, guys, we have been using this for the past 1 year. Looks like the utilization is increasing. Should we upgrade the network? Is there a capacity problem?" Right? And if you really look at it, right, the data is same. It's just that 80% link utilization, right? But the story is different. This is where AI can help and unify the perspective, right? And ground the conversation to a shared understanding and to explain to all the personas what it really means.
Hmm. So with all this complexity, there seems to be a turning point where industry they are realizing traditional tools aren't enough. What change that made AI not just helpful but necessary for network operations?
And I have been in the networking industry for 20 plus years, and what I have seen is the growth, right? If you see, look at the modern networks, it's growing very fast and changing based on the end usage, right? We changed from access to core from Web 1.0 to deep spine to 2.1. Now scale out and GPU networks, where it includes both east, west, and front end and storage networks all combined together, right? So as you can see, the data set and volume of telemetry requires an automated tool beyond human interpretation, with the customers expecting the one single goal, which is always on reliability. Right. So the industry, I think, is realized that humans alone cannot keep up with this pace. Right. AI is needed to synthesize and contextualize and predict for these modern networks.
Now, coming to the main question, right? There's a lot of concern that is going out about AI will replace engineers. What's the right way to think about AI's role in networking, especially from the perspective of the people actually running these networks?
Absolutely, absolutely. I think this has become the most wanted question among the engineering teams, and in fact, among the engineers in the AI era, right? I'll tell based on our experience at Aviz, right? We have been doing a lot of AI related work in terms of building the network infrastructure of AI and also using, right? From our we use AI in our day-to-day life, right? So according to our understanding, or I would say my understanding as well, AI will not replace engineers or engineering teams, right? Because we've seen it, right? Rather, what will happen is that engineers using AI will start replacing engineers who don't, right? Basically, um, um, the engineers need to adapt to this new AI era, right? To me, right, AI is an augmentation layer. Okay, first of all, it helps reduces noise. Second thing is it accelerates reasoning, and it preserves the tribal knowledge, and engineers can make it better, right? And most importantly, it bridges the skill gap in the industry that's scaling faster than the talent supply,
Hmm.
right? Engineers will still make the judgments and do the approvals and the architecture decisions for their own network, but AI simply ensures that they are operating at their highest leverage.
That makes sense. So when we talk about an AI co-pilot for networking, expectations they can be really fuzzy. So Chid, what should an ideal AI co-pilot be able to see, understand, reason through, similar to how an experienced engineer does?
Yeah. In my opinion, a true AI copilot for the network should have the end-to-end visibility similar to an expert engineer. That is the expectation. Right? Let's put it in the perspective of the network itself, right?
Hmm.
What does the expert engineer want? They want to know what kind of devices, in terms of inventory and health, is operating in my network, right? What are the configurations done as an intent in my network versus the actual, right? Are there any compliance variations or violations, right? Third one is the operational analytics, which includes the control plane, including routing protocols, and also what is going in the wire, the actual traffic. Then the fourth important is the anomalies, which happens due to utilization of your network, or some packet drops happening, congestion points, failures happening in the network. And finally, to support this network, what are the tickets, past incidents, and the tribal knowledge via runbooks, right? So these are something which should a should have the visibility to, and it will start reasoning like a senior engineer, right? So when I say start reasoning like a senior engineer, you should be able to answer questions like what changed in my network, what broke recently, what's the correlation across these events, and what's probably the most probable root cause for a particular issue or we are troubleshooting.
Hmm. And now we also know that not everything should be automated. So, which repetitive tasks or workflows are the best candidates for the AI assistance today without
Yeah.
crossing into change control or human judgment? Yeah.
No, absolutely. To start with, I would say, like, if you are new to this, is what we did at Aviz as well, right? So there are many high volume cognitive load tasks which AI can definitely offload and help, right? One is this, for example, if you want to do the compliance or check the compliance of the network, right? This what it means compliance. It can be two different things. Right? One is okay, are your softwares or firmwares running the right versions as per the design, as per the intent? Then the configurations which you have made, the policies which you have set, is it compliant to the entire network? This has to be done periodically because network upgrades happen, changes happen in the network. People don't just configure and then forget, but they continuously update the config, update the firmware and everything. So this has to be done repetitively, right? Second thing is keeping the security posture of your network. What I mean is saying that okay, patches for the CVEs or vulnerabilities or anything related to Linux Debian versions and all those things, that has to be up to date, and it has to be and it has to be made sure that the security posture of the network is aligned with the compliance, right? Third one is more on the operational aspect, which is like if I like to summarize the anomalies in the network, right? Like for example, there is a continuous spike in the traffic. There is a continuous drop happening over a period of time, right? And it happens at a specific time. Or system level utilization, which includes the CPU, memory, or the services going down, right? This summarization is needed to make sure that we keep the uptime reliable, right? And finally, simple correlation to reduce the alarms and alerting workflows, because not every alarm needs to be taken care. Put a human in the loop to fix that problem. Not everything is needed, right? It can be you can suppress the alarms and say that okay, you know what? For an example, the device is under maintenance, carrying less than 100 Mbps of traffic. This doesn't require to be serviced right away, right? You can adjust the thresholds accordingly to say that okay, how you want to utilize the NetOps team to do it, right? These start,
Mhm.
if you look at it, they are mechanical, right? But it's time consuming, right? So these are some of the candidates which I believe are for the AI Copilot. And by the way I'm saying is AI Copilot will augment it, not replace the human operation.
Now, these modern networks are hybrid and multi vendor by default. Why are tool agnostic, multi vendor, and hybrid AI deployments so critical? And how should organizations think about scaling AI without locking themselves into a rigid platform?
Perfect. So networks are inherently heterogeneous. Okay, there is no single vendor vertically integrated for any network, because there is no network where you have all the software and hardware from a single vendor, be it enterprise networking, edge, or firewalls, or if you want to do GPU fabric. It's a heterogeneous multi-vendor ecosystem, right? So
Hmm.
one of the things I would say is if your AI solution is tied to a single vendor ecosystem, then you are risking by creating new silos inside the AI tooling itself. By the way, which was not the intent for going towards an AI pilot, number one, right? The second thing is this brings the dependency on the vendor's roadmap limitations. If you go through a single vendor, you have to wait for it and say that aligned with the make a request to the vendor and probably get a solution on top of it, right? And most importantly, what you lose is the power to innovate yourself, right? Which is the most critical piece in the AI era, right? So vendor-agnostic architectures, right, ensures AI grows as the network grows. That's what I would say.
Hmm. Now, that makes a lot of sense. Another key topic is model flexibility, which is quite popular among our listeners. Being able to plug into different LLMs, how does that flexibility change the way organizations they adopt and evolve AI for network operations?
Yeah, this is a very interesting question because we at Aviz itself have tried have tried different models
Yes.
for various use cases as we have developed our network profiler product, as you know, right? So every
Hmm.
organization has different constraints if you're choosing a model, right? Depending on the use case, depending on the data privacy and the cost and everything, right? Being able to plug in the right model means you can optimize the performance and cost trade-off based on the use case. Smaller models can help with summarization of inventory and compliance, whereas larger models can be used for correlation across multiple data sources for troubleshooting an issue, right? Second thing is data privacy is critical. Whether your model needs to stay on-prem or you can run it in the cloud. That's another thing, right? Then the most important thing is you can evolve models without rebuilding the workforce or data pipelines, right? So model flexibility de-risks AI adoption and puts innovation control back to the organization's hands.
That's interesting to hear. Now, if we fast forward to a few years, what does network operations look like when AI co-pilots are deeply integrated into daily workflows? How does the engineer's role evolves?
Okay, interesting question. Let me think about it. So there are, I would say, three different shifts from the future perspective. What I have learned in the past, working across various AI use cases, and also from the networking perspective. One is it will move from proactive to reactive. What is that? Is what does it mean, right? AI will accelerate and catch early warnings long before the humans notice it, right? I use the
Mhm.
word accelerate here, by the way, right? So this is very important because
Hmm.
we do have workflows, automation systems in place, right? But the pace at which the networks are growing needs AI-powered human. That's what I would say. Second thing is declarative imperative. I would say, is what we are seeing within Aviz itself, and will be seen across every organization who have adopted AI. Because from my engineering perspective, right, engineers are describing the desired outcome, what needs to be done, and AI co-pilots are really helping the best path towards it, right? Whether with respect to troubleshooting an issue or supporting a ticket or developing a code, right? So we are AI co-pilots really help with this, right? And third one is it will be most knowledge driven rather than tools driven, because one of the things with networking is the tribal knowledge is very critical, and you have seen in the industry that a lot of organizations are creating their own model but leveraging their tribal knowledge and embedding into AI copilot, right? Because this is very important, because this reduces the dependency on individual heroes and enables the whole team for scalable operations, right? So what in a nutshell is, right, a network operations will become systematic, automated, and it will be predictable, and it will be purely data driven. That's what I see as the future with this whole AI co-pilots in the next 3 to 5 years.
Now coming to the another most asked question, which is your build versus buy, right? From teams listening who are constant considering AI for network operations, what would you say would be the first practical step they should take? And also as they plan ahead, how should they think about the build versus buy decision when evaluating AI-enabled networking platforms?
Okay, the fundamental answer is very simple, I would say, right? AI is only as smart as long as the data is good enough. Because that's a foundation for any AI model to work, right? So the first step for any organization, right, to make sure that you have the data for it, whether it can be network telemetry or configurations or change logs into a consumable format, right? So build scalable and cleaner data pipelines. That's the first step. That's where it all begins, right? After that, only you do use a model, train the model, or inferencing. Everything comes into the later, right? As far as build this buy, if you have a unique workflows and you have a strong ML teams and deep in-house NetOps expertise, number one, right? Buy if you are looking for time to value and integration out of the box and have standard workflows, right? But I would suggest a hybrid model, saying that buy a platform and customize to the last mile what you are looking for, because this will help with both, because you got a platform where you can see that okay what it can do, and then on top of it you can build your unique workflows and build the AI expertise within your team, and you can build a strong ML team with that platform.
Hmm. And finally, what mindset shift would you say is most important for leaders and engineers who are, thinking about embracing this transition successfully?
The biggest mindset, I would say, the shift which is required, I would say, is moving away from the belief that every engineer must personally inspect every log, every metric, and every alert. Right? That's one thing, right? At the modern scale, right, that's no longer humanly possible. It's not like completely, but the pace at which the networks are growing, that's not the right thing to do, right? Uh, uh, the teams need to trust on the assisted intelligence system that surfaces what matters, right, and filter noise and guide investigation as a co-engineer, as a co-team member, right? It's not about giving up control. It's about enhancing control through augmentation, so that you can make accelerated right decisions for your network.
Hmm. Chip, this has been an incredible, thoughtful discussion. It's clear that AI co-pilots aren't about replacing engineers. They're about giving them clarity, focus, and leverage in an increasingly complex world. Thank you so much for joining us. And to our listeners, if this conversation resonates with you, be sure to subscribe and share it with your teams. Thanks for tuning in. I will see you in the next episode.
Thank you, Shruti. Thanks for the opportunity again.